Good morning, everyone. So I am here to at least shed more light on a type of machine. There is a type of machine that I want to say something on. Not just say something on, but I know there is a question that has been bothering people. You understand? And that's why I'm here. So, but before I go into that question, let me say one or two things about machine. So a machine, some of you see us, you see some people defining a machine to be a device that makes work easier and faster. Fine. But to me, that's for a layman. To a layman, you can generally say a machine is a device that makes work easy and fast. Easier and faster. But to to me, I would say a machine is a device or a tools which allows a force known as the air force to overcome a resisting force known as the load at another point. So a device which allows a force known as effort to overcome a resisting force known as the load at another point is called a machine. Now, basically, I'll just say one or two about it. I'll just brief the whole thing. Now, note, you understand? We have what is called a perfect or ideal machine. A perfect or ideal machine is a type of machine which has no friction. Yes, it's a machine that has no friction. And since the machine has no friction, then its efficiency is 100%. So any machine that is frictionless, you understand, is called a perfect or ideal machine. That's not where I'm going into. Now, where I'm going to is, now having explained this, there are terminologies in machine. We have mechanical advantage. That's the very first terminology, or you call it force ratio. Mechanical advantage of a machine is when a large load is overcome by a small effort or little effort. You understand? And it's given by load over effort. I've told you, is that you call it mechanical advantage or you call it force ratio. So, or you see it as output forces over input force. You understand? The effort is the input force. You understand? That is for mechanical advantage. Then, another thing you have to know is that friction affects mechanical advantage in the sense that friction is dependent on mechanical advantage. Sorry, mechanical advantage is dependent on friction. That is, mechanical advantage of a machine depends directly on friction. That is, the higher the friction, the lower the mechanical advantage. The lower the friction, the higher the mechanical advantage. Vice versa. Are we together? The next terminology is velocity ratio. The velocity ratio of a machine is the ratio of the distance moved by effort to the distance moved by the load. Distance moved by effort to distance moved by load. That's about velocity ratio. Now note, velocity ratio is independent of friction in the sense that velocity ratio does not depend on friction. That's not where I'm going to. I will explain that some other time. Now the last terminology is efficiency. Efficiency of a machine is a function of the work done by the machine. And so you have work done by machine over work done on machine, work done on the machine, expressed in percentage. I said work done by the machine to work done on the machine expressed in percentage. Now, in here, do you know that the work done by the machine is a function of my mechanical advantage, while the work done on the machine is a function of my velocity ratio? 100%. Now, one thing you need to note is that for a perfect or ideal machine, then you have that the MA is equal to the VR. The mechanical advantage is equal to the velocity ratio. That's why you can have the efficiency to be 100%. 100%. Because the whole of this one gives you 1, and 1 times 100 is 100. That's not where I'm going to. Where I'm going to, we are about getting there. Now, let's move down to types. So, sorry, let's talk about the effect of friction on this particular efficiency. Since I've said it that friction affects this, definitely friction affects this too. You understand? The efficiency of a machine is dependent on friction. The higher the friction, the lower the efficiency. The lower the friction, the higher the efficiency. You understand the idea? So that is that about that. Now, another thing we need to note. Okay, let's move down to the types of machine now. Now, basically, the type of machine is where I am going to exit. Now, the very first type of machine is the lever. We have what is called a lever. Now, what or how do you identify a lever? A lever is a machine that has what is called a fulcrum. Yes, a fulcrum. A fulcrum is an axis of rotation. It's something that enhances rotation. Look at the scissors, for example. There's a, I don't know, there's a particular part, or let me use wheelbarrow. If you are moving a wheelbarrow, there's a part that enhances that wheelbarrow to rotate. In fact, look at my hand. Let me use my hand, my forehand. Look at this. Do you call it joints, Abi, in biology? No, but we call it fulcrum in physics. You understand? This is something that enhances rotation. The reason my hand can rotate is because of this part here. You understand? I can move it like this. And there are no two reasons, because I have what is called a fulcrum. So a lever is a device that possesses what is called a fulcrum. You understand? Two things are here. Load. So any device that possesses load, fulcrum, and effort, most importantly, fulcrum, is called a lever. Now there are three classes of lever. We have one. We have the first class lever, we have the second class, and we have the third class. I'm going to explain what the classes of lever means, and I'm going to give you examples of machines or devices that belongs to each of them. You understand? And this is where my question comes in. So for the first one, the first class lever is a kind of lever that has the fulcrum in between the load and the effort. So when you look at a machine, the first thing you have to note is, does that machine has a fulcrum? If yes, then it's a lever. Now the question is, where is the position of your fulcrum? If the fulcrum is in between the load and the effort, then you see that kind of lever is a first class lever. When the F is at the middle, be it E comes first, be it L come next, as long as the F, the fulcrum, is in between, is at the middle, it is a first class lever. An example is your scissors, your plier. You understand? Scissors, plier, and so on and so forth. These are examples of first class lever. Now, for the sake of the second class lever. Now, when the load is in between the fulcrum and the effort, when load is in between fulcrum and effort, that's why you have E, L, F. That's when L, the load, is at the middle of the effort and the fulcrum, then you call that kind of lever a second class lever. Are we together? The first thing you have to note is there this? If yes, it's this. The second thing is, where is this thing here located? Now, for the sake of second class, examples are wheelbarrow, nutcracker, and so on and so forth. Now, a third class lever is a kind of lever that had the effort in between the fulcrum and the load. So when the effort is in between the fulcrum and the load, then that kind of lever is called a third class lever. Examples are the thongs, you understand, forearms. Are we together? And so on and so forth. Now, my question is, before I ask you that question, do you know that a stapler is an example of a machine? Do you also know that a stapler is an example of a lever? Now, my question is, what class do you think a stapler belongs to? Is it a first class level? Is it a second class level? Is it a third class level? I know this question is a question of the mind. So kindly tell me your answers in the comment section. So let's contribute, and let's provide an answer. Thank you very much for watching. God bless you. See you on the next one.